Hello, thank you for joining. We will begin our program shortly. Today's program is brought to us by the National Science Foundation. In the chat, you will find a link to a research survey on STEM careers. Please participate in this important research and complete the survey. Thank you. Good afternoon. I'm Rubina Taliaferro, Director of Community Engagement for the Billion Oyster Project. Welcome to the 7th of the Billion Oyster Project's Near-Peer Career Panel Series, brought to us today by the National Science Foundation in partnership with Pace University and the New York Harbor School. These panels focus on middle school students to current high school students, college students and alum, and industry professionals in the ocean engineering program. At the end of the program, you will have the opportunity to participate in some important research with the National Science Foundation. During the panel, there will be a link in the chat box that will take you to the NSF research survey on STEM careers. We would like to have your input. Now, without further ado, I would like to introduce you to our Billion Oyster Project moderator, Avery Benz, who's currently a senior at New York Harbor School studying vessel operations. Avery.
Welcome all, and thank you for taking the time out of your schedules to join us today. My name is Avery Benz, and I am a senior in the Vessel Operations program of New York Harbor School. Today, we are going to be meeting with panelists that undergo a career in ocean engineering, as well as some Harbor School students and alumni. Throughout this meeting, we will be discussing the different pathways that our panelists took to get to where they are today, along with exploring the difficulties and successes of this field. We hope that this discussion will help you gain an understanding of the things you might want to know about this maritime branch. Without further ado, here are the names of our panelists. Harbor School student, Lindsey Askin, Harbor School alumni, Robert Bailey, and professional panelists, Casey Saul, VHB engineer, Brian Wilson, who works in Giro UAS, Richard Sherrill, who works in a company called Cyclops Research and Development, John Paul Turner, Billion Oyster Project engineer, and Rick Lee, New York Harbor School teacher. I'm going to ask the panelists that when I call your names, you turn on your camera and mics to give the audience a brief 2-minute background about yourself and how you ended up in this line of work. When you are done speaking, please turn your mics and cameras back off and wait for the discussion section of our meeting. Casey Saul, may you please start?
Howdy, everybody. My name is Casey Saul. I work for a firm called VHB. I work primarily in renewable energy and then more specifically in offshore wind. I've been working in offshore wind since 2007. We work in the planning stages of offshore wind to help developers get the permits and the necessary approvals from federal, state, and local regulators. Our work helps to inform the engineering of these projects. And currently these projects are being developed all up and down the East Coast, with projects here serving New York State being located out 13 miles south of Long Island, and then as well as projects south of Massachusetts. Would you like me to add anything else, Avery?
No, that's completely good. Thank you. You may turn off your camera and mic and wait for the discussion portion. Brian Wilson, may you continue?
Yeah, hi everybody. My name is Brian Wilson and I'm the co-founder and CEO of Giro UAS. We make environmental monitoring devices specifically for water quality. Always have just had a passion about the environment and water. and really excited to be here.
Sounds awesome. May we have Richard Sherrill next?
Hi, Dr. Richard Sherrill. I have a company called Cyclops Research and Development where we design deep ocean sampling equipment, specialize in sediment sampling. We look at doing background studies. We also do work dealing with searching for microbes that may have good antibiotic or good biological activity that we can use for the development of drugs and industrial enzymes. Thank you.
No, thank you. John Paul Turner, may you come up next, please?
Yeah, hey everyone. My name is John Paul. I'm a mechanical engineer for the Billion Oyster Project. I work with a very talented team designing systems and structures that help restore oysters to New York City's waters. So we restore oysters for habitat and just for like the ecological benefits.
Doric Lee, may you please give your introduction? Or Rick Lee, it's my bad, I'm sorry.
That's okay. Hello, my name is Rick Lee, and I am the Ocean Engineering instructor at New York Harbor School. The Ocean Engineering course is a career and technical education course, just like the 6 other courses that many of you may have seen, that focuses on the fundamental aspects of engineering, working with groups, working on long projects, a lot of planning and development, and then some of the technical aspects of electrical engineering, building circuits, doing programming, and doing computer design.
Thank you. Lindsey Askin, may you please come up next?
Hello, everybody. My name is Lindsey Askin. I'm a junior at New York Harbor School, and I'm currently in the Ocean Engineering program. I got here I was very, very interested in robotics when I was younger. I did a lot of Lego robotics in grammar school, and then from there I went into becoming a student of the Billion Oyster Project in my environmental club at school. And from there, I learned about the New York Harbor School and, got in and came here. And then I decided that ocean engineering was definitely the right track for me because I've been on it my whole life.
Thank you. And lastly, but not least, we have Robert Bailey. And I'm pretty sure your camera is broken, right?
Yes, I apologize about that. But to make up for it, I'm actually the person in this poster. I'm pretty sure if you've been to the Harbor School, you've seen it at least. That's me like 5 years ago. But yeah, I'm an alumni, class of 2019. I currently go to SUNY Maritime in the Bronx, and I'm studying to be a mechanical engineer. I don't have any other certifications. Well, I do. I took a NOCTI test when I was actually in Harbor, and I passed that. But I'm still learning a lot to get on the level of everyone else in this panel.
Thank you for sharing. Thank you all for your introductions. And now we will begin the discussion portion. Will all the panelists please turn on their cameras to begin? I'm going to ask questions either directed to all of you, specifically to professionals, or specifically to students or alumni. If you want to answer, you may simply unmute your mic and speak. Please respect one another and await your turn if you want to answer the same questions. And to the audience, if you have any questions, you can write them down in the Q&A section of our screen, and we will try to get as many in as possible. And please make sure that it's in this Q&A section and not the chat, because it will be easier for us to read. Okay, so first question is, this seems like a large field of study. What types of jobs can one pursue? This goes out to professionals.
Yeah, this is Brian Wilson from Duro UAS. And one of the things that's exciting about this field is it does lead to a wide variety of opportunities, whether being an actual engineer building or developing technology like Dr. Richard Sherrill, to being a field technician and deploying and gathering data. So there's really a wide variety of opportunities and different types of careers that are involved in ocean engineering as a whole.
I can give an example where I actually took a job at the Metropolitan Museum of Art to determine authenticity of artwork, really to learn how to use a particular machine called an energy dispersive X-ray analysis system, or an XRF. And we had a machine back then that was called Son of Death Ray. And it was a 13 collimated beam of X-ray that shot out to analyze paintings. And I used it for analyzing deep sea stones underwater. In other words, basically magnesium nodules can be used, this same technology can be used to analyze these samples. So you can go from one area to another. And so there's a variety of things in ocean engineering that you can do by being in other fields.
Awesome, thank you. Second question also goes out to professionals. Engineering is a field that typically requires a college education. What types of skills do students learn in an engineering class that might transfer to real-world employment opportunities that may not require a college education?
Yeah, I can answer this one. I think there's a lot of crossover between what students learn in ocean engineering and kind of like intro or entry-level technician jobs. Like even a lot of trade jobs now are getting more and more high tech. So you're seeing like jobs like a machinist used to just be working with your hands, and now you're actually working with computers and like really advanced robotic systems, even as a tradesperson. So if you're interested in trades or thinking about joining engineering or some career that doesn't involve college, ocean engineering is still a really good way to get familiar with a lot of the technology that you'll face in these jobs in the future. So things like construction are being more and more automated. So there's construction robots now, machinists, there's a lot of data analysts and like data collection jobs. And these are all things that are touched on in ocean engineering.
In the offshore wind, thank you very much for that, John. That's John Paul. That's exactly right, that there are tremendous opportunities in ocean engineering outside of the professional degrees. In offshore wind, because this is a new field, the state and other entities are offering workforce training, particularly aimed for students of your age for the future of this industry. And these folks will be utilized for the ongoing maintenance and operations of these offshore wind turbines. It would be a great opportunity to combine what you would learn in your preliminary ocean engineering along with practical work offered again by these workforce institutes, generally by unions as well as local workforce training. So I definitely keep an eye out for those and look for those opportunities.
A follow-up to that question, would you say that it's harder to get a job under this field without a degree?
I would say so. For me, I would recommend getting a degree in order to best understand the complexities of the offshore world, particularly when it comes to something like offshore wind, in which we would utilize the skills that John Paul, certainly that Brian and Richard have, and many of the other folks on this call. You need to be able to understand the intersection of business and engineering, development, science, economics, law, and that would better help you to be able to understand how these elements fit together and how you could best find your niche and find the area that you would best want to enter that world while still staying within the ocean environment.
Yeah, and this is Brian, just to kind of add on to that. And I'm a chair for something called the Advanced Robotics Manufacturing Institute. And the whole purpose of this initiative is to upskill and reskill people for advanced robotics manufacturing. And KC touched on this. So while some people think of a degree as a long-term program, we've just launched a website called roboticscareers.org. And we're developing programs. Sometimes it's a one-year program or two. Maybe you have a current skill set and you just need to get a certification to get that skill, to get those jobs. So training is definitely important for all of you. But there's really a lot of different opportunities for training that are out there that aren't necessarily a long track. So definitely keep aware of a lot of those things that are happening out there, especially with the newer technology, which is the exciting thing about this.
Thank you. This next question goes out to mostly students and alumni. How is what you are currently studying preparing you for a career? How might the career relate to ocean engineering?
I can answer this one. What I'm currently studying has to do with a lot of electrical engineering, and I'm pretty sure everybody kind of touched on this, that ocean engineering is very broad and it can be a lot of different things. And electrical engineering, is very important in most aspects of any career now in engineering, because it's right now everything's being, digitized and everything's in computers, and machines are, basically running the world right now. So electrical engineering, which I'm learning right now, should be a very large component in that, if I get a future career in ocean engineering.
I could follow up with that on the college level. I could say, when you first come to college, at least in your freshman year, you're taking a lot of basic classes, but all of those are just building blocks for the heavier classes in your junior and your senior year. I'm going into my junior year, and this is when we're going to start taking things like heat transfer, fluid dynamics, which are basically applying all of the math classes and skills we learned freshman and sophomore year. But there's also skills like John Paul said, like machining that we learned. And while that's not like a mathematics class or anything, it's very important, because sometimes if someone breaks, you can't solve an equation to, fix it. You have to physically get with your hands and take a piece of metal and build it to what you need to repair the thing that broke. So in the college level, they give you a multitude of skills, not just cognitive, but hands-on. And that can apply really to any profession, whether it's mechanical, especially ocean engineering, and electrical engineering, and everything in between. So those are my thoughts about it.
Thank you. What would you like people to know about ocean engineering? The difference between the things like the difference between the class title and the various fields of engineering along those lines. This goes out to anybody, by the way.
Well, I haven't spoken yet, so I can kind of speak to that. Since I chose the title Ocean Engineering as the title of the course and created the course, it was my intention that that really what the course was an introduction to general engineering and general engineering principles, which applies to a lot of different careers. So you have electrical engineers that design circuits, you have software engineers that design programs, you have computer programs, you have mechanical engineers that design all types of machinery, civil engineers that design bridges, and even right now, the vaccine, figuring out the different variants of the virus that we currently have, the different various variants of the COVID-19 virus, the machines that they're using to do that are all developed by engineers. So engineering is so broad, it's really hard to just put it all into one little shell and call it, and expose everybody to the same thing. So So what I wanted to do was create a course called Ocean Engineering that touched on as many aspects of that as I could, but also some of the fundamental things of engineering, in that you're really fundamentally trying to solve problems, and you're trying to use math, science, and technology to solve those problems. So that's kind of how it differs. Ocean engineering is a pathway that you can take. There are colleges that offer ocean engineering, but most of the students really are just getting exposure to just some of the basic principles of engineering, hopefully getting excited by being future problem solvers. So,
I have a follow-up question specifically for you, Rick. When you're first starting off your CTE program with freshmen, how do you engage them into getting into ocean engineering? What is some of the first steps that you take to get them into what they're going to be learning for the rest of their high school career?
I think one of the things that I try to do is first of all, have them doing something hands-on, have group projects where they're working as teams to solve some type of problem. In the past, it's usually been to build an underwater vehicle of some kind, like an underwater robot of some kind, and then competing with each other for design, for like which one would have the best design. And that touches on a couple things. One, students learn a little bit about how mechanics work, and two, they learn how to manage a project, a long-term project, because it usually happens over the course of a couple of weeks. Three, they learn how to work with one another as a team and share ideas and successfully motivate each other to collaborate and finish a product. And I think that there's a little bit of an element of competition to it. So, of course, everybody loves games and people like to win. So that, I think, motivates the students to kind of do their best on a project when they realize that they may be evaluated against their friends, and they have plenty of opportunities to if they lose, to turn that around into a win. So I think that's a motivating factor for me.
Thank you. Would anybody else want to share something that they want people to know about ocean engineering?
One of the things that I noticed that when I was in college, I think when I noticed that the variation from being in regular school, which didn't matter what program you were in, to when you changed programs. So I went to school for ocean engineering. And when I took my first ocean chemistry class, that's when the world changed. In other words, the chemistry that we took for ocean chemistry was much different than the med students took or any of the other students took at school. So I think that was a big change. And I go back a while, so we still did everything by titration. In other words, we didn't have computers, we didn't have fancy equipment. We did it by the old-fashioned chemistry methods. And I think that's when I noticed that taking a degree in oceanography shifted when ocean chemistry came in. And that's when I noticed that we were doing something far different than all of the other students in the university. And that was the first class when I actually saw that, oh, this is a big difference. And so that was one of the things that I take away from my education, that the ocean chemistry side really took us in a different direction than almost everybody else was going.
Richard, I think you're exactly right. When you take the engineering and you combine it with science, particularly when it comes to the ocean, you're taking your education and your abilities to a whole new level. And to be able to combine the engineering of exactly what Rick went through, which was so insightful, to talk about aeronautical, mechanical, electrical, these different engineering firms, and then combine them with science, particularly with regards to the ocean, because the ocean is so complex, huge, demanding, that it needs a special way of thinking. So again, if you can combine that engineering with chemistry, biology, geology, benthic, avian, you know, all of these different sciences, you're allowing yourselves access to a greater level of understanding and capabilities. So it's great, Rick, that you're able to introduce your students to engineering and give them practical applications of these opportunities as well.
Thank you. Next question goes out to all again. What are some ways people from this field are making a difference in this world, and how are you personally trying to make an impact?
I'll jump in there real quick. So my work is to create renewable energy to decrease the amount of carbon and greenhouse gases in this world. So we're trying to reduce climate change and make the world a cleaner and better place through the use of renewable energy.
Yeah, and this is Brian from Duro, and our whole mission was to create really affordable environmental data collection devices, because the more data we have, especially real-time data, the better we can forecast and understand all the important things that are happening along all of our coasts and all of our waterways. So that was a big one for us, and data is power.
Would any students or alumni like to hop on?
Well, I mean, I'm not in the industry right now, but with the skills I get, I could probably take a job in one of those fields with renewable energy, research other forms too that are very experimental. I know there's certain nuclear energies that that are thorium based, that don't melt down like a uranium reactor would. So I could probably take my engineering knowledge and bring it there or anywhere else.
I can give you some examples where ocean engineering brings you out to a variety of different fields. I designed deep ocean sampling equipment. And some of the things that people don't realize when you're working in the deep ocean is that we have things like the ideal gas laws. The ideal gas laws are said that way because they only work to a certain pressure. Once you go beyond the pressure that those ideal gas laws work, you can't do certain things. So for instance, I design equipment that uses gas to do work underwater. But when you go beyond 5,000 meters, there's no mathematical equation that tell you how the gases operate. So you have to go and come up with inventive ways to figure out what volume of gas would you need? How would you do something where you need to use gas underwater? And it ends up that you actually have to design and build your own equipment to do this. So when you go into designing a piece of equipment, like some deep ocean sampling equipment, well, one you had to figure out is how the animals are going to survive in this environment. And when it's a gas-filled environment, how will oxygen work? So you end up having to learn a lot of fields that you never even thought about. So for instance, I'm a biological oceanographer originally. I'm an ocean engineer now. And for me to work with taking up live animals from the bottom of the ocean and keeping them alive on the surface, I had to learn fields far different from what I started in. So I had to learn about how gases affect the organisms. I had to learn how much oxygen concentration at depth at let's say 16,000 PSI would affect organisms if they're breathing a gas now that they would normally breathe in water. So all of these things came up where you had to learn different fields, completely different fields. So I went from needing to know information about biology to thermodynamics to ocean engineering, all to build a single device. So there are a lot of technologies that are required to conquer any single problem underwater. In fact, I do a lot of work with the guys that build the Mars rovers. And we look at each other as like, well, going to Mars, going to another planet is really difficult. Well, guess what, guys? Going underwater to the bottom of the ocean is more difficult than going to Mars. So there are a lot more problems going underwater than are going to another planet. So you really need a wealth of knowledge to be able to do some of these more difficult projects. And so you know, in my field, I had to learn biology, genomics, chemistry, engineering, just to build a single device. So there's a lot of aspects in ocean engineering where you can bring a team of people together to do a single project. So having, you know, you may end up being an ocean engineer without ever thinking of it, just because you know an aspect of biology that somebody needs in ocean engineering. So you might be surprised, but there's a lot of areas that you can lend yourself to ocean engineering by taking another field. With wave energy, permitting, believe it or not, one of the most difficult things in getting a wind project set up is the permits to be able to get the cables from the wind project onto the land. So even people with law degrees end up specializing in ocean engineering. So you'd be surprised at the different fields you can be in to get into ocean engineering. Thank you.
Thank you. I have a question specifically for students and alumni. What are you looking forward to as you continue your studies? What do you plan on doing in your future that you're excited to do that involves with ocean engineering?
I can partially answer this. So as a junior in high school, I have to look at colleges and figure out, you know, what I want to do with my life, more or less. But I'm actually really excited to figure that out. I know that's really weird, but I know that I'm going to be using every aspect that I've learned in high school in ocean engineering, trying to figure that out, because it's all stuff I love doing. So, you know, I feel like that's one of the things I'm most excited for, is trying new things and using the knowledge I have gained in high school to, you know, figure out where else I'm going to go in life.
Yeah, building onto that, coming out of my sophomore year of college, it was really eye-opening because a lot of things I was interested in with various fields relating to engineering, I think a lot of the knowledge I'm getting now, you can apply it to certain things, not even just ocean engineering, but things you might just do around your house, interesting things. Like if you're into cars and everything, or if you were doing something with ocean engineering as well, you need a power supply, right? In a car that's like a gasoline engine. And a lot of ROVs use electric motors. And one way that I know cars, you can find the horsepower of an engine is you hook it up to a dynamometer and you rev the engine up to its max limit, and you get this curve. And to find the horsepower, you need to use calculus to find the area under the curve, and that would give you total horsepower. And I just found that interesting because I finished all my math classes, and it's like, I could do that now. I could find the horsepower output of a motor, an engine, things like that. And I think that's just only a little bit of what I could do. And I'm thinking what I could figure out when I learn thermodynamics, things like that, and machine design. So I'm really excited to learn more when I get into my junior year.
It's awesome. Thank you. Next question goes out to all panelists. How could we advance this field, and what steps are being taken to make it more diverse?
I would say that Brian and Richard are probably working the hardest to advance the field, utilizing the latest technology and furthering the science. It's important that we think about industry in terms of how we further science. So how do you build upon what is already known, and how do you expand it so that you can adapt to future environments and capabilities accordingly? So just take, for example, knowing the bottom of the ocean floor, what's there and what are the conditions. We're constantly learning more and more about these conditions. And so it's important to be able to build upon that year after year. And then getting to your diversity question. it is important for all companies, particularly companies like mine, large engineering firms, to represent the communities that we work in. And we work very hard to recruit, to first of all, support schools accordingly, to support students accordingly, and then to recruit accordingly.
Yeah, and I can kind of add on to that. And, diversity is important. And, here at Duro, located in the South Bronx on the Harlem River, we have a very diverse team. And it's just like the environment in what we do. It's, it's a diverse environment. So obviously the workforce should be diverse as well. And it is important to constantly develop new technologies and constantly look to, once again, learn more and gain more knowledge that helps improve the lives of kind of everybody, no matter who or what they are.
Thank you. With respect to ocean engineering, what are the most critical changes that we must take to face the future effectively? This goes to all panelists.
Well, there are a lot of areas of ocean engineering that really encompass a large area. And we have everywhere from oil exploration, which is turning down a little bit, but will always be with us because nothing right now creates as many BTUs or as much energy as oil does. Wind energy is now the next big thing. And the reason is that I went to school in the 1970s for college. And when I was there, I went to the first school that, quote, taught environmental engineering. And it's been this many years since 1974 when I started that we're still fighting this battle to do the right thing. And I think that as long as we have people out there that are trying to do the right thing, we will eventually get there. But it's been a long battle, and it's not like we haven't tried. The group of students that I went to, we were so gung-ho, we tried to change the world. The world is a tough place to change. So right now, we're depending on the students like you guys to really make this change. And it's something that we're trying to do. Here at Duro, we're trying to make changes by building instrumentation that is less costly than this equipment that's out there now, because third world countries just can't afford it. So we're trying to build equipment and instrumentation that will allow us to monitor our oceans and seas to make sure it stays healthy. And it's not an easy thing to do. My deep ocean sampling systems, we're in the middle of a pandemic. I design equipment that's for bioprospecting in some ways. And in part of that, believe it or not, nobody wants to fund this kind of research. Nobody wants a cure for a drug. Nobody wants to do this. So all I can say is that we need youngsters like you guys to go out there, get these jobs and move into them and force our government to put money into areas that will help support people, find us new drugs, find us new methods to do things. These are the things that we need. And I've been doing this battle since the 1970s, and it still hasn't moved very far. So we really need students to keep pushing this because it's the most important thing we do. Our environment is our world. And I always tell people, if you throw it on the ground, it's going to end up in the river or the ocean. So never throw anything on the ground because it will end up there. So we try and we're trying to get everybody to understand that this battle has been going on for a long time. And we really need people to continue this. So I may be a legacy from the 70s that tried to start this, but you guys now have to finish it and make it work because our environment is the only thing we have left. And we have to keep it healthy and keep it moving for all of our grandchildren to have a place to live that's really healthy and well. So, I look at it as like, we're still doing this. We're going to continue doing it. We have somebody doing wind power, which is something that, it took years for us to be able to get this in there. We need battery technology. We have no battery storage technology today. We need this kind of people. We need people going into this field so that we can store the energy that comes down from windmills and from solar panels. So there's a huge area where we need people, young engineers, to go into these fields to keep this going and doing this. So I really believe that, you guys are the future. And I hope you guys can take on the challenge and go where, well, we haven't quite gotten to yet. Thank you.
Yeah, I think broadly, engineers are really good at like, let's say 2 main buckets. They're really good at developing new technologies and making existing technologies cheaper or more effective. So if you look at both those buckets, both of those are, you can kind of separate every technology we'll need in the future into one of those buckets. It's like, we already have solar power, we already have wind power. We just need to make it cheaper. We need to make it so more people can have access to it, and we need to make sure it's more effective. New battery technology, that's something that doesn't exist right now. So we need engineers to develop that. So if you kind of look at those 2 buckets, I think there's a lot of different kinds of engineering and a lot of different problems that are really exciting for engineers right now that'll have a huge impact on the future.
Thank you for sharing. And our last question of this portion is, what is one piece of practical advice you can give to students interested in going into this field?
So if you are a student that is interested in pursuing ocean engineering at any time in your life, you know, something that's really you have to mainly focus on is teamwork. So, you know, being able to communicate with others, being able to talk about your ideas, but not just as your own, as the groups. It's very important that you know how to communicate. I think that's the key to at least a success. I would say, I don't really know, but you know, to a happy group, to learning more, is just being able to communicate really well.
I think one thing students should know is that you shouldn't put all your eggs in one basket. I know a lot of you like doing ocean engineering, and it's certainly a really great career, but you can become an electrical engineer and still work on underwater robots. Like, engineering it's not cut and dry like I think a lot of people thought it would be. Like, I thought it was cut and dry when I first went into college. But as a mechanical engineer, I could be working on stuff from like in a factory to one specific system on a robot that will be going underwater. You know, you could actually have aerospace engineers working on things like this. It's not, you have to become an ocean engineer to work in the ocean engineering field. You can specialize in one area and still work in this field.
This is Casey, and I'll just offer that a good way to look into this is just to do some basic Googling. Look at Google offshore wind. Watch some videos about how it works. Understand where you can enter the field. Once you have studied some of the basics, you can then ask more informed questions that will allow you to learn more and more. And then finally, when you're ready to work, start modestly and enter in on the ground floor. You know, offer to be somebody's assistant. Get some experience working as a deckhand or as somebody's, cleaning in an office. Learning the terms, spending time, finding a good mentor are all the ways that you can enter the workforce and gain experience and build upon it and build upon it and build upon it.
Yeah, that's a great one, Casey. And another thing I'll add, and we've taught a lot of our students that come through our intern program this, you can go on to sites like LinkedIn and type in that title as a job. You'll see all the people that have that title, and you can look at their profile and kind of walk back through their career like, oh, wow, look, they went to college, they became, an entry-level person. Oh, then they went to something else. And then when you really can start to see how other people just mapped out their career and the different things they touched to achieve those end goals. So that at least you get an idea on what they did to get there.
I started neurophysiology. I started doing surgeries on octopus and things like that. So it took me from oceanography, where I was working with marine organisms, into a whole different direction. And it was because that I learned electronics to understand the brain. So when you learn the analogy of electronics to study the brain, Well, if you can get more money doing electronics, guess what? You're going to do it. So I ended up changing my fields because I could make money doing something slightly different.
Thank you. We will now begin the Q&A section of the discussion. The first question that we have from our audience is, what are the ways of bringing ocean engineering and conservation projects together?
Yeah, I think I can answer that because that's basically what I do. I think a lot of major conservation projects right now have an engineering component. I would say all of them actually. A lot of the conservation projects and restoration projects have like engineered systems in that. And so that can be like building a new seawall that new creatures can live on. It can be building habitat like we do at the Billion Oyster Project. But a lot of these big conservation projects have problems they need solved, and they have things that need to be built and things that need to be moved around. And those are all kind of big, broad categories where engineers can slot in and help out. So I think there's a lot of crossover between conservation and engineering these days.
I think like another interesting thing, at least from when I was in school, I know one of the things we used, especially to make oyster colonies, is we had these metal, like the boxes, and MST would weld them. And you might think, well, an engineer design, I think John Paul, you would make them in CAD, right? So you might think, oh, that's just a metal box. Why would you need an engineer to make that? Well, the thing is, when you're working in marine environments, certain metals oxidize differently. So you might need an engineer who has, or a material scientist, to figure out what metal would work best in this type of water. Like New York City's water is brackish. So there's salt and there's fresh water, and there's all these other different organisms that would impact a certain metal that you use to make the colony. So you don't want to build a box to grow an oyster colony that's going to disintegrate and oxidize within like a year. So that's where engineering, I think, actually comes into Billion Oyster Project and why you need them in conservation projects as well.
Yeah, Robert's exactly right. It's a lot of like engineering to make sure the structure that you use for conservation actually works, and then also making it as cheap as possible. Because if you have a set budget and someone says, here's $1 million to go restore this habitat or help out this environment, if you want to maximize your bang for the buck. And so an engineer, if you're driving the cost down of all those structures, you can restore more of that environment. You can do more with what money is given to you.
I can give an example where, for instance, in the oyster cages, if we took those oyster cages and coated them with talantinum, that would last forever. They would never corrode. They'd have no problems. But money is the thing that we don't have. And so when you're designing something that, yes, we can make it this way, but it'll cost us a fortune to do it, or you can come up with an engineering solution that becomes cost effective. A lot of engineering has to do with cost effectiveness. If we can make it and it costs too much money, it's not going to be made. So we constantly think about designing equipment, designing instrumentation so that it's cost effective at the same time. And every project requires that. You have a budget, you have to work within your budget. And a lot of engineering has to do with getting something to, making something that we can make within our budgets.
Thank you. Another question is, have you heard of using old potato starch as a cage?
I don't know if I've heard about potato starch, but we do use a lot of, we're exploring a lot of plant-based plastics for oyster cages because they biodegrade. So if you want the oysters kind of take over eventually, it's a really good material that we're looking into.
Thank you. Do you travel for your job?
I personally do not, especially this last year, but I have friends who are like service engineers. So one of my good friends, he works for a laser company, basically fixing giant industrial lasers, and he travels all the time. He travels to, you know, different continents and all over the United States because he's the lasers, you can't ship them around, so he's got to go to the laser. So he travels all the time. I think engineering is a broad enough field where if you want to travel, there are definitely opportunities for like jobs that allow travel.
And I travel for my work, usually mostly up and down the East Coast where offshore wind farms are being developed. but I've also traveled to Europe to look at previous wind farms that have been completed in Europe and to look for best practices as well.
And for my research, I also traveled. We go out to sea, so we go different coastal areas where you have to catch the boat or catch the vessel that we're going out on, and we go out to a certain place in the ocean. So there is a lot of travel. It depends on where the project is, where the grant is towards, and so you can actually. What's nice about ocean engineering and doing these oceanographic projects is that you can almost choose where you want to travel by selecting the kind of grants you want to work on. So there can be travel involved, or you can work in a system where there's no travel involved. So it's really up to you on how much travel you want to do. But there can be lots of travel involved in oceanography. We go from the Arctic to the Antarctic, to the East Coast, to the West Coast, and around. So it tends to be an area where you can get to see the world if you so want to.
Awesome, thank you. I don't know if it's a good question. All questions are good. But what brought them into their job or passion? What led you guys to leading this way?
For me, I went from, I actually, one of the interesting things I did was, and I think everybody should do this, and almost all the people that I know that are professionals in their field that went to school for it, almost everybody took an internship. If they stayed in this field, pretty much that meant they took an internship somewhere in high school or college, and then they proceeded to work in their field. So I think that, going out and being able to when you go and do an internship and you start to learn about the field, you start to look at it in an area that you actually enjoy, and then start working in it. So I think that, doing this, it's one of the good things that you can do to become an intern. It's probably will take you the furthest and get you to see the most that you've ever seen before. You get so many experiences by doing this. So I really believe that going out, trying to take an internship someplace, then taking that education that you got from that and utilizing it is probably one of the best things that you can do.
I got into engineering because I liked race cars. That's the honest answer. I really liked, I thought race cars were really cool when I was growing up, and then I wanted to work on those. So I majored in mechanical engineering at a school with a really strong automotive engineering program, so I could do that. Like Richard talked about, I got an internship at a company that built engines and realized I didn't want to work on race cars professionally, but thankfully engineering is a broad enough field, enough opportunities to where I was able to pivot really easily after that internship. So you don't need some greater passion for engineering to get started in the career field, or at least explore it more. You can literally start off with man, rockets are cool. And I know tons of people who have PhDs in astronautical engineering just because they're rockets are really cool. I want to work on rockets. And that's the thing that got them going. So you don't need to know exactly what engineers do. You don't need to know exactly what you want your future career to look like. You can kind of just think something's interesting. And really the field is about curiosity. It's about exploring things that you think are interesting and eventually getting deeper and deeper into that.
When I was about 9 years old, my dad took me to the American Museum of Natural History, waiting for an interview to go to another school. And I saw guys walking around with a little badge. And I saw that, and I saw this place, and I sat there and said, oh, someday I want to be here working. And lo and behold, when I was about 13, I got my first job working at Natural History Museum as a volunteer. And it took me the rest of the way. I literally interned to the museum through high school, into college, and even after college. So, and that's sort of what bloomed me to do this stuff. I originally started working in marine science, dealing with taking care of an animal called an aplysia, which is a snail that doesn't have a shell. And it's a hermaphrodite, so it's a male and female at the same time. So I worked in behavioral science. We did all of these interesting experiments dealing with this organism. And that took me into neuroscience, where I learned about how to study brains of organisms. And from that, I grouped out into other areas. So I got to work on on rodents and cats and rats and all kinds of things where I took their brains out and studied what happened to them when we put them in certain experiments. And again, from that, I somehow ended up in ocean engineering because there was more money to be made in electronics than there was in brain research at that time. Whereas today, right now, there's more money to be made in brain research than there is possibly in electronics. So with the push, the initiative to learn about the brain that we have out right now, it's not a bad field to go into. But I'll say that my experience in going in and learning these different fields and taking steps by step to get to where I am today, I think was really exciting. And I wouldn't trade it for anything.
As a student.
Oh, go ahead. Go ahead.
Thank
you. Go
you.
ahead, Lindsay.
Just to add on to that, as a student, in grammar school, and now kind of, but since quarantine, not as much, tried everything. I did any extracurricular program my school offered, basically. And from there, you know, whether I did Lego robotics for a very long time, I did Girl Scouts, I did, you know, environmental club, I did soccer, I tried everything. And from there, I kind of realized that in each field, I definitely did have an interest, but my biggest interest for the longest time, I also tried art, and my biggest interest for the longest time was architecture. And from there, and including now, going into high school, I've done things like ACE of Greater New York, which was architecture, construction, and engineering mentorship, where I would meet with real people that would tell me, you know, things about their career. And from there, I really found out that I like engineering the most. And, you know, and luckily for me, I had chosen ocean engineering as my path for high school. And from now, I kind of am just going with what I've been learning since, you know, first grade, which is engineering. Like it's something that I really do love. And, you know, I think at any time I could be anything that I wanted to be, or, you know, like if I want to change my career and be an architecture, all the things I've learned in engineering go with that. So I think that's something that I really am happy about.
I appreciate that, Lindsay. Working hard while you're in high school in order to allow yourself greater opportunities once you begin to study at university level is a great idea. And particularly for those who are the participants on this call, I think what you can begin doing is not worrying too much about exactly what you're going to study at the university level right now, but instead work hard while you're in junior high school, while you're in high school, and allow yourself to be open to all of these new fields, particularly fields that are on the cusp of the newest thinking, and do that research, dig in, learn more, and again, be open to new ideas.
Thank you. As time cuts short, I would like to say if any of the panelists have any more things they would like to say, any last words? Thank you. Okay, well, thank you all for giving us your time today. And as we wrap up, I would like to pass the mic back to Rubina.
Yes, thank you, Avery. And thank you once again to all of our panelists for participating and joining us today. Thank you to the audience for joining us. Please participate in the NSF Research Survey. Your responses are important to us. Stay safe and be well, everyone. Thank you. Bye all.